Hello everyone, today we are going to be solving AQA Chemistry Specimen 2018 question paper. This is a foundation paper. Today we are going to be solving from question number 1 to question number 4. So this is the part 1 video. This question is about different substances and their structure. So draw one line from each statement to the diagram which shows the structure. A substance is a gas. We know that gas molecules are going to be, large distance apart. So this should be gas molecules. The substance is a liquid. Liquid particles, they are closely but non-regularly arranged. So this should be liquid. The substance is ionic. When substances are ionic, they have both positive and negative ions. So this should be ionic substance. The substance is a solid metal. Metals have positive ions with C of D localized electrons. So this can be metals. Figure 1 shows the structure of element. We can see graphene, graphite. A single layer is called graphene. What is the name of this element? So the name of the element, actually graphite is made from carbon, so the name of the element will be carbon. Why does this element conduct electricity? Alright, you see graphites have delocalized electrons in between the layers which can move. So this delocalized electron, they can conduct electricity. So it has delocalized electrons. Figure 2 shows the structure of an alloy. We can see an alloy. We can see that there are, large metals X, metal atom X in combination with metal atom Y. So this is basically a mixture. Explain why alloy is harder than pure metal. Alright, so the particles or the positive metal ions are of different sizes. So there is no layers so that they can slide over. Since there is no layers that can slide over, that's why it is harder to basically, change its shape. Alright, so that's why they are more harder. So guys, the portion in the bracket is just written for your understanding. You may not need to write that in your exam. Next, what percentage of the atoms in the alloys are atoms of X? Okay guys, so for this one, we need to count the number of atoms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 20, 21, 26, 27. So out of 27 atoms, 2 of them are metal X times 100. This gives us 7.4%. What type of substance is an alloy? We know that alloy is a mixture of two different metals, or like a metal and a non-metal. So it's a mixture. A student investigated the reactivity of 3 different metals. This is the method used. Placed 1 gram of metal powder in a test tube, add 10 cm³ of metal sulfate. Wait 1 minute and observe repeat using the other metals and metal sulfates. So copper sulfate added with zinc, we can see a displacement reaction. What is the dependent variable in the investigation? Okay, so the dependent variable in the investigation is, you can see either there is a reaction or there is no reaction. So the dependent variable is whether there is a reaction or not. Give one observation that the student could make that shows there is a reaction between zinc and copper sulfate. So when there will be a reaction between zinc and copper sulfate, copper sulfate solution is blue and zinc sulfate solution is colorless. Alright, but copper metal by itself is, you can call it like brown metal, let's say. Alright, pinkish brown, okay. So we will see brown metal will appear. Alright. So there can be two observations. We just need to write one though. So guys, we choose to write any one of those answers. The student used measuring instrument to measure some of the variables. So draw one line for each variable to measuring instrument used to measure the variable. So mass of metal powder. All right. So if we want to measure the mass of metal powder, we will have to use a balance. Volume of metal sulfate. If we want to measure the volume of a solution, we can use a measuring cylinder. Use the results shown in table 1 to place zinc, copper and magnesium in order of reactivity. Okay, so let's see this one. We can see zinc reacts with copper. All right, we can see magnesium also reacts with copper. We can see magnesium cannot be reacted with zinc, copper or magnesium. Zinc can be reacted with magnesium. That means magnesium is the most reactive because it could react with both of copper and zinc. So magnesium will be the first. All right, and copper couldn't react with, as you can see, copper couldn't displace any one of them in the solution. So the least reactive will be copper, and in between will be zinc. Suggest one reason why the student should not use sodium in this investigation. The student is not going to, shouldn't be using sodium in this investigation, mostly because it's not going to be safe, first of all, and it's too reactive. All right, so it will be like really dangerous. Which metal is found in the earth as the metal itself? We know that gold can be found as nuggets, so gold. Iron is found in the earth as iron oxide, Fe2O3, similar to that of rust. Okay, now balance the equation for the reaction, guys. Here we have two iron, here we have one iron, here we have a carbon, here we have a carbon with two oxygen, here we have three oxygen. In a situation like this, all right, balancing, first of all, we can try with balancing the iron. Okay, let's see. Let's try with the iron. There are two irons here, let's put it two. Okay, once we get two irons, there will be three oxygen. To make three oxygen, we will have to multiply here 1.5. When 1.5 is multiplied with 2, is going to make 3. But that will make the carbon 1.5. And this will be 1. So since there is a half in the equation, so we multiply everything by 2. So this becomes 3. This becomes 4. This becomes 3. And this becomes 2. So 2, 4, 2, 3, 4, 3. Name the element used to reduce iron oxide. So we have used here, in this case, carbon. So just write carbon. What is meant by reduction? Okay, guys, oxidation is gain of oxygen and reduction is loss of oxygen. So Reduction will be loss of oxygen. Lithium carbonate reacts with lithium carbonate reacts with dilute hydrochloric acid. A group of students investigated the volume of gas produced. Place a known mass of lithium carbonate in a conical flask, measure 10 cm³ of dilute hydrochloric acid using a measuring cylinder, pour the acid into the conical flask. Place a bung in the flask and collect the gas as shown in figure 3. Okay, great. So we added dilute hydrochloric acid with lithium carbonate and we're gonna get gas. Perfect. Figure 4 shows the measuring cylinder. We can see the measuring cylinder. Okay. What volume of gas has been collected? Volume. All right, great. So we have to read it upside down. This is 30. This is 35. So this should be 36. So the volume is 36. Table 2 shows the student's result. So we can see mass of the lithium carbonate, and on the other side we can see the volume of gas in cm³. The next question says plot the results in the grid, complete the graph by drawing 2 straight lines of best fit. Okay, great. What are the 2 possible reasons for the anomalous result? So we can see the volume of gas collected is less. It should have been higher. So the possible reason could be that the student was unable to put the rubber bunk in time. The question says too much lithium carbonate added. The bung was not pushed in firmly enough, could be a reason. All right, but then in that case, most of the gas can escape. There was too much water in the trough. Too much water does not affect. The measuring cylinder was not completely over the delivery tube. This possibly could be a reason. Some of the gas escaped. Bubbles when they try to rise up. All right, they can go left and right, and some of them can escape. The conical flask was too small. The volume of conical flask will not affect, unless otherwise it's just too small. It's not going to affect, all right, the collected gas. So this could be the 2 possible points. Describe the pattern. The graph shows up to 0.4 grams of lithium carbonate added. So up to 0.4 grams of lithium carbonate added, we can see there is a steady increase in volume of gas. Okay. So it's like proportional. Lithium carbonate decomposes when heated. The equation shows the decomposition of lithium carbonate turning into lithium oxide and producing carbon dioxide gas. Figure 6 shows the apparatus a student used to decompose lithium carbonate. We can see lithium carbonate in a boiling tube, and then it is being heated with a Bunsen burner, and the gas CO2 produced is bubbled through lime water, which basically tells us, all right, that whether CO2 was evolved in the process or not. Why does the lime water bubble? All right. So the lime water bubble is basically carbon dioxide is produced. All right. That to show that. if you have thought of that, you're gonna write that the air in the tube has expanded, you can still be correct. So we can write the student repeated the experiment with potassium carbonate. The lime water did not bubble. Suggest why there was no bubbles in the lime water. You see, potassium carbonate does not decompose on heating. So as a result, there will be no bubble in the lime water. A student investigated the reactivity of different metals. The student used the apparatus shown in figure 7. Thermometer, dilute hydrochloric acid, metal powder. Okay. The student used 4 different metals. Great. The student measured the temperature rise for each metal 3 times. The student results are shown in the table. So calcium, iron, magnesium, and zinc is used. Okay. And the temperature, rise in temperature is calculated, the average rise in temperature. Okay. Now give 2 variables that the student should control so that the investigation is a fair test. In order for this experiment to be a fair test, since we are adding this particular metals to an acid, the volume of the dilute hydrochloric acid, the concentration of the dilute hydrochloric acid should be the same, and the number of moles of calcium or iron or magnesium or zinc, the number of moles should be the same. All right, or we can say similar mass, same mass of metal should be used. So even though they only gave us only 2 marking points here, there can be multiple points. Let me give you all of the answers, and you can choose 2 best answers for you in the exam. So guys, the points written in the green are basically the extra points. You may choose to remember them in the exam, just in case if you forget the original ones. All right, then this can be alternative points that you can write and also get the answer correct. One of the results for magnesium is anomalous. Which result is anomalous? Suggest one reason why the anomalous result was obtained. So we can see both of the values in test 1, test 3. Sorry, both of the values, both of the values in test 1 and test 3 for magnesium, they are similar. However, test 2 has a significantly lower temperature, like 4.2 degrees Celsius. So the result, we can say test 2, 4.2 degrees Celsius. Okay. Or we can write magnesium test 2. Okay. Now the reason is maybe accidentally for the experiment a lower mass of magnesium was added. All right. Or the solution was not stirred properly, or not reacted for as long as time, all right, as the other metals. So there can be there can be difference in surface area as well. So there can be many reasons. We can just give a better one, all right, a best answer. So we can just simply say lower mass of magnesium added, which will give a lower temperature change. Calculate the mean temperature rise for calcium. So for the mean temperature rise for calcium, all right, calcium had 17.8, 16.9 plus 17.5. So 17.8, 16.9, 17.5. We divided by 3. We'll have to use all of the values because they're close, they're similar. So the answer is 17.4. So 17.4 degrees Celsius. The temperature rose when the metals were added to sulfuric acid. Give one other observation that might be made when the metal was added to sulfuric acid. How would the observation be different for the different metals? Okay, all right. So the question says the temperature rose when the metals were added to sulfuric acid. Give one other observation that might be made when metals are added to sulfuric acid. Okay. So when we add the metals to sulfuric acid, see, metal plus acid will produce hydrogen gas. Since it is going to produce hydrogen gas, we're going to see bubbles. All right. And since sulfuric acid is a stronger acid, we're going to see bubbles more quickly. So guys, the reason why we wrote more bubbles is seen with calcium than other metals is because, out of all of the metals that are shown in the list, calcium is the most reactive metal. However, guys, there is a little bit of fact check in terms of this answer. All right. Technically, this particular answer is not correct. I'll give you the reason why. You see, the problem with calcium is that even though calcium reacts with dilute hydrochloric acid, dilute sulfuric acid, it's more reactive, but in the moment when calcium comes in contact with sulfuric acid, it produces an insoluble layer of calcium sulfate on top of the on top of the metal, all right, that comes in contact with sulfuric acid, and immediately the reaction ceases. So we will see that there would be a lot of bubbles in the beginning. The reaction is quite vigorous, but immediately the reaction will stop. Whereas on the other case, iron sulfate, magnesium sulfate, or zinc sulfate, they are highly soluble in water. So they keep on reacting. So this question is like in the gray area of being correct and wrong at the same time. Anyways, guys, let's continue. Aluminium is more reactive than iron and zinc, but less reactive than calcium and magnesium. Predict the temperature rise when aluminium is reacted with dilute hydrochloric acid. Guys, with iron and zinc, the temperature that we get is, iron and zinc, the maximum temperature that we get is 7.8. And with comparison to magnesium, the maximum temperature that we get is 12.4. So, if the temperature rise, we give somewhere in between 7.9 to 12.3, it should be correct. So you can just guess anyone, like 10 degrees Celsius, let's say. Let's say you guess 10 degrees Celsius. 10 degrees Celsius will be correct. Alright guys, we are done with question number 4. So guys, in this question paper, we're supposed to solve until question number 4. And in the next question paper, we're going to be solving from question number 5 to question number 7. And in the next question paper, in the third part, we're going to be solving from question number 8 to question number 10. Guys, questions, answers like this, videos like this are going to be uploaded daily. All right. We are done with the foundation paper with this particular specimen paper. And in this next series, what we're going to do is we're going to solve the higher tier paper. All right. Higher tier paper 1, chemistry AQA. And once we're done with that particular list, we're going to move to paper 2. Obviously, maybe probably like similar serial, like maybe the foundations first and then with the higher tier, and then we're gonna move to biology question papers, guys. So guys, subscribe to the channel, stay with the channel, all right, and support the channel by letting your friends know that question papers like these are being uploaded. Watch the video from beginning till the end and solve with me. All right guys, best of luck with your exam. See you in the next video. Bye bye.